continue. Yeah. I found some problem. So look, this place, this is not right. Yeah. So let me correct it. Yeah. All right. Here, I use this chance to review our two shifting theorem, first shifting and the second shifting theorem. Okay. All right. First shifting theorem and the second shifting theorem. Yeah. First we call S shifting, right? Yeah. First is S, second is T. All right. Yeah. So let's review a little bit. First, it's S shifting. Second is T shifting. Second, T shifting with U function. Okay. First shifting, no U function. All right. So here, this is wrong, yeah. Because here S shifting, we should use the first shifting theorem, S side shifting. So we should use the first shifting. First shifting, then e to the 2 pi t, yeah, opposite direction. Okay, the first shifting is the coefficient part, and this shift number, the sign is opposite sign. Okay, yeah. Opposite sign. Opposite signs. All right. Times, yeah, we do shifting first, and then inverse Laplace transform 1 over S. 1 over S, it's 1. It is 1. So then you get e to the 2 pi t, because it is 1. All right, yep. And T shifting. T shifting, same sign. Yeah. Same sign. Not opposite. Okay? All right. So that's something like this. Yeah, let me use this way. E to the pi S over S squared. Yeah? This is the situation we need to apply second shifting theorem, T shifting. Yeah. This E term, we need to use second shifting. All right. Same sign, yeah? Pi, all right? Yeah. All right. First, we need to calculate inverse Laplace without that E function. That's T, right? That's T, all right? Yeah. Then we do shifting at the T side. Yeah, T shifting. At T do shifting by this pi, same sign. So T plus pi and U T plus pi. Okay. Yeah. All right. Yeah. So we review it. Although you can look at the formulas in the textbook or notes. Yeah. So you can. Yeah. But here, in our understanding, we should have some basic understanding. Yeah. All right. Then, in our part A, this time I give you a question. Part A. Yeah. One question related to two shifting theorem. Yeah. What's that? Shifting. Now I ask you. So you have you have a S-side function like E negative AS, for example, times F S plus A. Okay? Yeah. This form, then I ask you, can we apply both first shifting theorem and a second shifting theorem? Both. You can use both. Okay, to find the inverse Laplace transform? Think about this question. Based on your understanding of first shifting, second shifting, can we apply? So you can use any order to apply first shifting, second shifting. Yeah. Yeah. Suppose f of s inverse Laplace transform is known, okay, is f of t. Yeah. I didn't ask you to write out the inverse Laplace transform. I just ask you if you can find the inverse Laplace transform by these two shifting theorems. Yeah. One of the questions in part A. Yeah. All right. Another one. Yeah. So this one, yeah, too. You need to calculate separated. Here, the numerator part, shifting theorem. Second, t shifting. So you can ignore that numerator part, consider 1 first. Find the inverse Laplace transform for that 1 first. Then you do t shifting. Yeah. All right. The first one, yeah. First one, yeah. Because the denominator you want to write, complete square version, right? Yeah. So after that, then 4. Yeah. So s plus 1. Yeah. So there is a f shifting. How to handle this plus 1? S shifting theorem. First shifting theorem. Right. Then, yeah. So the constant part, this part. Yeah. All right. Then, because to take care of s plus 1, you have this e term, e to the negative t. Yeah? So first shifting theorem, look at it. The sign is opposite. You have plus sign here. Then, for this e function, you need to use the negative 1. So opposite direction. Okay? All right. Yeah. So cosine omega, 4 square. 4 is 2 square. So omega is 2. Yeah. All right. Then second one, yeah. So yeah, shifting, right? T shifting part. Take care of this plus 1. So then sine. Yeah. Yeah. Try to get used to. Yeah. 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 You can always use the formula. Yeah. Yeah. Then this one we need to split. Yeah. So this one split. Yeah. Yeah. Actually, yeah. Here, what I do split is this one. The first round, yeah, because first round you may not get your destination immediately. So the first round, yeah, because 2 factors, I just split these 2 factors, do subtraction. Yeah. When I do subtraction, yeah, numerator has something. Numerator has 2s plus 4, right? Yeah. 2s plus 4, so I should put the 1 over 2s plus 4 to balance the formula. Then this factor, I take constant 1/2 out. Then 1 over s plus 2, yeah, I need to do another round splitting. Yeah, this is the first round splitting. I need to do second round splitting. Yeah, yeah. Sorry. Yeah. Yeah. Here. Oh, that's another one. Oh yeah. Yeah. Let me just do another round splitting. Yeah. 1/2. Plus 2. All right. This is relatively complicated, yeah. But my midterm question will be simpler than this one. Yeah. No. The technology is not very stable. Yeah. It happens frequently. All right. This one split, yeah, natural split, right? Yeah. So here, when you see a question like this, when you do split, basically you do the natural split, natural way, right? Natural way is this. This is natural way, subtraction of. But when you do this, yeah, because quadratic form, linear form, yeah, you want to cancel out s squared. To cancel out s squared, you want to put s here. Yeah. But the plus 2, actually, plus 2, we use the difference of two squares formula, right? Yeah, this formula. Minus 2, that, the linear term is gone. So s squared minus 4. So you use this way. This way, yeah, because the plus 5, right? 5 over s plus 2 times s squared plus 1. You need some experience. Okay? Here are based on my experience. Yeah. Based on my understanding of the structure. Yeah. So my understanding of the structure. How to make it, balanced things, yeah. Cancellation, I need to see the possible cancellation. Yeah. So this way, then these two fractions, when we do inverse Laplace transform, we will feel easier and easier, right? Yeah. All right, so that's this. And how about the split here? This split here, we do the natural splitting, like this. Then we need to make up a little bit. Yeah. In this numerator position, we need to make up a little bit. Okay? Yeah. Because when we put appropriate numerator there, we want to do nice cancellation. Nice cancellation. So here I put an s. S, do multiplication, s times s squared. S squared cancel out. S times 2, 2s cancel out. Yeah, nice cancellation. Right? Yeah. So you can see that's the way I do. Yeah. Then remaining 5, yeah, s plus 2, s squared plus 2 plus 5. 2s. Then, but we need to multiply 1/5. In this way, we can do the splitting. Yeah. Yeah. So based on some experience, although, yeah, you can use partial fraction method to do it. Yeah. Yeah. For me, although I can also use partial fraction way, but I can do this way much faster. Use my observation. Yeah. I do the splitting quickly. Partial fraction, you need to A constant, B constant, C constant. Then you need to multiply out a long formula. Then you compare. Right? A lot of work. Yeah. A lot of work. Although you can use online calculator to do it. Yeah. Oh, probably online calculator can do the partial fraction decomposition, right? Yeah, I believe. Yeah, because it's not hard. You just enter the fraction, then you click equal, then you get a split. Yeah, I believe it. Yeah. Yeah, I can try it. In that way, you can use online calculator to do it. Yeah, it's legal. Yeah. It's legal. Yeah, yeah, because I saw it. Yeah. Sometimes, because the answer it will give many different forms. One of the forms must be that partial fraction decomposition. Yeah. One of the forms could be. Yeah. In that way, then it won't be too hard, right, for you. Because after the split, then you do the inverse Laplace transform using the basic formulas. I hope in this way, you won't feel very hard when you work on Laplace transform. Yeah. All right? Yeah. There. But although there is another one, yeah, but this one not actually it's not hard. Easier than the previous. Previous one we need to do split. This one, this denominator, we do not need to split. We only need to, get the numerator right. So this one actually much easier. Yeah. All right. Yeah. Then I think I have a last topic to talk about initial condition thing. But before that, because here we have a lot of space, right? Yeah. Yeah. Let me use the space to talk about one of the Module 1 questions. Module 1, 4 questions, right? 4 questions actually. Most of them are pretty straightforward. Yeah, pretty straightforward. Yeah, yeah. Comparing with the sample questions, I just change a little bit. Yeah, not much change. Yeah. But the one of the 4 I want to talk about a little bit. Remember that bug problem. Bug. Move from A point, yeah, the coordinate given, B point, coordinate given, and you apply the directional derivative, right? That question. All right. Now I modify slightly. Yeah. The function is also the same. Yeah. The t function, same. Yeah. I didn't change the t function. Okay. Same function. Yeah. A point, B point, I do not change. A point, I only make one small change in this question, but I hope you know how to do it. All right. What I did, the bug moving, okay, moves from A point to B point along this straight line segment. Yeah. Now, I'll tell you the bug moves to C point. Okay, yeah, C point. And I give you the information, yeah, because somewhere between A and B, yeah, yeah, you know, then I tell you the length of AC line segment. AC line segment, I use this absolute value to represent the length. Okay, length of AC equals 1/3 of the line segment AB. Yeah. I tell you the information of the C point. Then I ask you to calculate rate of temperature change at a C point, not at A point. Yeah. Yeah. Small change. Yeah. The question, do you know how to calculate the coordinate of C point? Yeah. Very easy. Yeah. There is formula. Calculate. Very easy. And remember that interpolation formula I gave you last time. 1 minus lambda times a coordinate. Yeah, a coordinate. Okay. This is linear interpolation formula, right? Yeah. Yeah. For all the points on this line segment can be represented by this linear interpolation formula, and the distance, location of the point on this line segment can be controlled by this parameter lambda. Right? Yeah. Yeah. Here, think about at a point, lambda equals 0, right? Yeah, you plug in 0. Yeah. B is gone. Yeah. At a B point, lambda is 1, right? Lambda is 1. Now, at a C point, based on this information, C point, lambda is 1/3. How about that? Moving from 0 to 1, okay, in a linear way. Yeah. You know, yeah. Average, yeah. You know, those, you know, changes in a linear fashion, right? Yeah. So 1/3, so lambda is 1/3. Okay, in this way. So you can find the C coordinates. Then your directional method. You know, you just change a different coordinate, right? Because the direction, that U vector, that does not change, right? Yeah. That U vector, when you move on the same direction, the U vector does not change. The only changing part, the C coordinate, changes. Yeah. So when you calculate, you use the C coordinates. Yeah. So that's the third problem in module 1. Total 4, so this is the third one. Okay. Yeah. All right. Then the last question I want to talk about. Related to Laplace transform, but our focus is at the initial condition. It's not at the inverse Laplace fractional, like that part. So how to do the initial condition correctly? That question I want to explain. Yeah. And we have a question I need to explain. There is some subtle step we need to consider. Yeah. So this question. Question 11 of our homework assignment number 2. Yeah. All right. In this one, everything is normal, yeah. But here, 0 initial current and charge. The question, how to use it correctly? I want to explain this question. Yeah. There is a correct way, but there is another different way, incorrect. Yeah. But some students may go that direction. Then you will get a different answer. Yeah. The first time I did that way. Yeah. Yeah, later, I found. Yeah. So there is some problem. All right. Let's look at the equation. Yeah. So after we write equation, this is our original equation. Yeah. Original equation. Okay. We know there is 2 methods. One method is take derivative. Take derivative, you may go to the wrong way. Yeah, so here, I want to explain. Yeah, so let me take the derivative first. You may go to the wrong way for the initial condition wrong way. What I mean initial condition? The Laplace transform still correct. You can do it. But that initial condition, if it's different, then your Laplace transform will be different, slightly different. Yeah. All right. I double prime I prime of t plus I of t c equals v prime of t. Yeah. All right. Then the problem occurs at the initial values given, so no problem. But the problem at 0 for this derivative value, I prime of. And may have some potential problem. Okay? All right. All right. What's the problem? Let me point it out. Let's find a v prime first. V prime, very simple. Okay? All right. So negative 34 e to the negative t. V prime. All right. Then let's plug in t equals 0 into this equation. Okay? Yeah. All right. Oh, sorry. Oh. Yeah, not into this equation, because this equation double prime, right? Yeah, sorry. Yeah. T equals 0 into this equation. How about that? How about that? Okay? Yeah? Because we want to find I prime of 0. Yeah. Here. We do not need to, yeah. Because when we apply Laplace transform L on this equation, we need I prime of 0, right? Think about it. Yeah. When we apply, look at this. Transform square capital I minus S times 0 minus I prime of 0, right? That's the formula. In that place, we need to use this value. Okay? Yeah. Yeah. So if we find this value, plugging here, then we may have trouble. Okay? Yeah. Let me try. L times I prime of 0, R of I0, Q 0 over C equals V of 0. What is V of 0? V0 34, right? Yeah. The limit. Yeah. So we can look at the limit. All right. 34. 0. Initial value 0, right? Gone. Okay. L is 1, right? L is 1. So this, we will get I prime of 0 equals 34. If you use that value, so you will get a different solution, and it's not correct. It's not correct. Okay, so avoid using this value. Avoid, because value. So avoid. Avoid this one. Why this way? Avoid. Now I want to explain. Okay. How to avoid them? I show you how to avoid. Yeah. Why avoid? The derivative when you look at the derivative at the endpoint 0, it does not make sense. There is a problem. It does not make sense. Why? Now look at this. If you draw the v function, what is the v function? V function. From 0, t, 4, right? You cut here, 4, okay? Between 4. So something like this decreasing function here. Cut that 4, the 0 point, this point. Think about this point. How to choose a reasonable derivative value, right? Yeah. Although you can choose this one, yeah. But how you know how to connect to the left hand side, right? So there is no reasonable way to define derivative at a 0 point. That's why we want to avoid. If you choose some point, it's pretty much like a random point, random value. You know, it does not make sense. Okay, so that's why we want to avoid. Okay, yeah, it will cause problem. How to avoid? Next, I explain how to avoid. Okay, how to avoid? Do not use this version formula. Okay, so this derivative, in this case, do not use it. Use this original equation. When you apply Laplace transform, you apply it on this original equation. Integral, don't worry, we have integral formula, right? Laplace, yeah, because Q equals integral of I. Q of t, integral of I of tau, d tau. Yeah, integral. So when you apply Laplace transform on little q function, you just apply on this integral of I function. We have formula, right? The formula very simple. Capital I of s divided by s. Divided by s. So simple. So we should not try to get rid of integral function, right? Yeah, we keep the integral. Yeah. Here, you apply it, because the good thing is you never need to use the I prime of 0. In this case, you never need to use I prime of 0, right? So we take a Laplace transform, L of I prime t equals s times I of s minus little I of 0, right? No I prime. So you never need to use I prime of 0. I prime of 0, that's a sticky point. Yeah, don't touch it. I prime of 0. Don't touch it. Okay? Yeah. Yeah. In this way, you don't need to use I prime. Okay? Yeah. Every step, okay. Very smooth. Yeah. So we have one question. Our last question, similar to this one. So when you work on the last question using this one, do not use this equation, this I prime value, Then because you will get different answer. The different part is caused by this I prime of 0. Yeah. Okay. Yeah. That's the. Yeah. I will post my solutions. Yeah. If you still you have some doubts, so you can use my solutions. Yeah. When you work on this is our last question. You only need to memorize one thing. Yeah. Do not use the I prime of 0 value. Then you can avoid the potential problem. Do not use I prime of 0. then you will be fine. Yeah. You find a solution without using I prime of 0, then you will be fine. Yeah. Yeah. All right? Okay. Yeah, so let me stop right here. Yeah, I have some time, so I need to upload the PDF file to the Canvas. So